evaluation, not a group effort, ladies and gentlemen. I appreciate your indulgence. Here we go. Back to slide one.
Do you want us to send like the photo of the quiz to your phone number or to your email?
I would send it to email for with my old phone. We thought that when I got my new phone, they did not place all of the stuff on the new phone, but there's other complications. I'll be talking with you as soon as we get into the conference, but thank you for asking. Ladies and gentlemen, I think that we're still probably missing one person, but I'm going to go ahead and start. Um, the first thing I'd like to talk about a little bit is your homework. I am currently evaluating homework, and before I do, let me just say that I believe 3 or 4 of you got a message from me, but it may also be applicable to some of the other students that did not get an email from me earlier this morning. It appears that what I thought was a problem with transferring information from my old phone to my new phone during the last weekend of May has been resolved. There was not a problem. We had a complete transfer of anything that you text to my old phone, including pictures. And for some reason, a lot of you that sent emails or something like that apparently went to, if you went through Canvas, it went through FSCJ's scam identification, and it was then sent to Cluttered. When I, last Friday, went on to complain that I had some students that had quizzes and homework that never appeared anywhere on my phone or in emails that I have, they did a little research and they suggested I go to the Clutter, and indeed I found almost all that was missing. However, if checking your quiz grades, you do not have a grade, please see if you can go back and find where you submitted the quiz and resubmit it, because somehow if you went through an email at the college, it put you out into a Clutter category, and we can get that back or resolve the issue. For those of you that got the email, I also last week, I think already indicated to you by email that I did not get something, and you have already sent me both your first and second quiz and resubmitted also your homework. Many of you both to chapters 1 and 2. So I have those of you that I sent an email to this morning about this problem. I think you've already resolved the issue even before you got that email, and I appreciate it. I could say I regret that it happened. Computers are not perfect. Certainly online is not perfect either. I've admitted that, and I hope that it never happens again. Let's put it like that. A system should be able to identify students that are in classes, and when they don't, and they call it scam, it's embarrassing. And I apologize to the college. It set us back almost an entire week of getting organized and used to ways of doing things, and I'm not happy about it. Okay, folks. The next thing is homework I've been looking at is a lot of you just send it, and if you send it by text, it ends up just being a phone number. And what you need to do is, in the text, you need to identify yourself, because I do have 2 classes. And just the last name will be fine. And you might identify it as being, say, if you want to say 8, which means you're in 2048, just your name and an 8. And then when I pull up the file, I know what to expect. If you have a quiz, I know you're taking that and trying to get it to me in a hurry. So if it does not identify as homework, I'm going to know that it's a quiz, just to save a little typing space. And that will give me a little more guidance. And so when I'm grading quizzes, I go into that folder and I recognize where they're at. And I also recognize homework. In the homework, if you identify, particularly when you're submitting 2 chapters of homework, like we're doing today, there is homework for 2 chapters due tonight at midnight, and it'll be chapter 3's homework in addition to chapter 4, although there's not very many in chapter 4. I would appreciate that, because it also identifies which chapters I'll be grading. A lot of you are not showing the correct number of steps using the methods of science. If you're using any equation, even if you're doing a conversion factor, like in problem 11 from chapter 1, you need to identify what you're doing. And if you're talking about, say, a volume, you need to identify by the methods of science dictate that that be a capital V, as opposed to a capital A, which can represent area. And when we're talking about electricity, it happens to be an ampere, but we're not into electricity. Part of the methods of science is to identify the equations first. Second, you should substitute the data that you're using or the numbers you're using. And at a minimum, a third step would be your answer with proper units identified. But when it's possible, you should include units in the substitution of the data, unless you're dealing with calculus, and we've encountered that already. If you're dealing with calculus, we suppress the units until we get to the final variable, and by common knowledge, length hopefully is in meters, which means you want to make sure that everything that was substituted in your integral notation or differentiating has the same units. Don't mix centimeters with meters, because once you take the derivative, it gets a little confusing. Your text uses the metric system, which is kilogram, meters, second. Labs generally will use the CGS. However, virtual labs generally use the kilogram, meters, second to help clarify things a little bit. I'm going to ask that you don't piggyback your emails on a general information that I've sent to many students, which means the next homework you submit, please make sure that it's an individual email, because when you piggyback on an email that I may have sent you, there are hidden files that I may not see. Again, this is where I discovered some files that were not evident this weekend. And believe you me, I searched everywhere I could to find missing the quizzes and homework. So try to send an email that is between you and me and has not been piggybacked on any other email that may have gone to another student. A lot of you have sent me data that you collected from the first virtual lab. Some of it has been very well done. The data tables a little hard to read, so you may want to practice using maybe a black pen. It's pretty standard to use either dark blue or black in writing in methods of science, any kind of data that you want to publish or share. And I find that a lot of you are not, if you send me a photograph, you're not putting the page down flat. Make sure it is on a flat surface and there's plenty of light, and you've used dark enough ink. And a lot of you, if you'll take a little more time writing, I don't mind if the spelling is not that great. I know that when you're taking a picture of something, you don't have spell check. But I will try to identify all the words that you sort of misspelled. Excuse me. And unless you keep misspelling the same word, I forgive that, especially with online labs. I'm trying to give each one of you some feedback when you do send me a preliminary lab. But except for one student, the lab material you've been giving me is not in a scientific method of any kind. And remember, we sort of shortcut folks, I'm busy trying to teach, and yet I've got some chat going on. So what should be the primary method of sending you our assignment? Through Canvas email, which is fine, Um,
Sorry, I wasn't chatting you. I was just giving suggestion people.
yeah, use the Genesis scan. Is this Justin? Okay.
Yeah.
Yeah, okay. In other words, it wasn't a question because, see, I'm busy teaching and talking, so if you ask me a question, I won't see it until much later. And actually, Justin, you're right. If you've been using that, it does make it super visible. In fact, it makes it very manageable. So I've been trying to feed people information with regard to the visibility, whether or not I can shrink it or enlarge it. Most of you know that I can enlarge any document better than I can shrink it.
Yeah, we're using it in my Calc 2 class, and it works well. So.
Oh, yes, thank you. And I see students unable to view the homework assignment. Also, Sierra, what do you mean by the homework assignment? They're in the calendar.
Yeah, so whenever I go into Canvas and I look at my calendar and I click on the assignment that says it's due on that day for homework, it literally
No, don't do that. Go back to the original where it says 1P, which means 1 p.m. That's the class. Go up in there and click on that huge, it looks like a cloud or something, and it will tell you the activities for the day and what is due that day.
a cloud.
Well, it's the first thing in the calendar where it says 1P, and then I think it says something like conference required. Click on that.
She has the
Okay.
actual homework numbers on the date she assigned it, not the date it's due.
Okay, thank you. That helped.
No problem.
Oh, yeah. I thought we went over that on the first day, but with all the trouble we had the first day, moderate problems we had on the first day conference, that may be where it slipped through the sentences, I think. What numbers to do? Okay, I've had some critical. I emailed you about this before, but you must not have seen it. You're right. Sierra, spam has been a problem. And I have just this morning finished talking with the dean, and she agrees that if you are enrolled in a course and if you're a professor, you should not be scammed. And yet I have, according to the tech team, a lot of spam. Don't know how it happened. I do know that that first couple of days of both classes, the weather was terrible.
Oh yeah, everyone
Yeah.
got an email from that Israel Rice dude asking him to email him from his private email because his uncle's in town. Report that dude to the frickin' police. That is so, like, that just screams scam. So please,
I got the same email and I looked up. So he's going to like send you like his uncle's email so you can like pet sit for him. And that email's a scam. Like it's looking to get your address and all of your kind of like bank information so that he can like pay you to watch his pet. It's like a really bad scam.
Yeah,
like
it's called phishing. Don't
Okay.
click.
Wait a minute. I didn't get that, or if I did, it's still in spam, and they've already done something with it. Can you type out what it looked like?
It's only sent to the naive students.
It was only sent to students?
Yes, because younger people are typically more naive, and students are typically younger than teachers and faculty.
Thank you for that. I appreciate that comment. If you can just tell me what it was, maybe, and I can get it back
in the comments. So I reported it to FSCJ, so they're gonna like somehow delete the email. But yeah, definitely don't email this person from your private email because they can hack into your stuff.
Okay, that sounds a little like what may have happened. As soon as that happened, I don't know when it happened, but it may have been the cause of every student he sent it to, they considered it spam. So if you got that, ladies and gentlemen, there may be either a quiz or a homework that I never got and I didn't find in spam. If you have not got a grade for quizzes 1, 2, I don't think it happened in 3, or homeworks 1 or 2, because I've only got homework for about 2/3 of the class so far. And chapter 1's homework was pretty easy to do, so I'm sure if it's lost, if you want to take a few minutes to do chapter 1's over again, but let me give you a clue. The only problem in chapter 1 that you want to study for the test is problem 11. I'll just give that secret out to you after what's happened to us, because I have spent, I don't know how many hours trying to rescue stuff. Did everybody hear that? Let me print it out.
So, ma'am, if you have some quiz grades in for us, but not the homeworks,
All right, I haven't finished the I haven't finished the homework because I want you to get everybody's homework graded the same, but it should be completed. I'm hoping if it doesn't get blown up like it was Saturday. I knew something was drastically wrong on Friday and Saturday, and I got it unraveled for the class I have at night. And the reason I did their class first is they have a test Monday, and your test does not happen until the 18th, which is further away. I hope you understand that. Now I'm working on this class, and it looks like they messed up this class more than the other class that I have tonight. Oh my, I'm really ticked off now. Okay, chapter 1, problem number 11. Whoops. Problem number 11 is important.
also, for the quizzes and the homeworks, how will we be notified of the questions that we did wrong?
You mean you're not talking about the quiz now. I hope you're talking about homework. Are you talking homework?
Either?
Well, the quiz is really not directly on your test. You realize that?
Yes, ma'am, but I still would like to know where I went wrong or what I did wrong.
Well, I can get it to you, but I need time.
Yes,
I'll
ma'am.
need some time. Yeah. I've made notes of all the quizzes and what you missed. And it's a matter of time, ladies and gentlemen. If I didn't have this spam problem, I would certainly be more caught up. That's why I'm really ticked off here. It was a time waster. And I had the tech team, Canvas even looked at it, and they felt that what happened was external to Canvas, but I'm not so sure. Of course, you got to consider what was going on, the weather. Okay. Here we go. Chapter 1, problem 11 is to be studied. So if you got caught up in the spam thing, and we got put into clutter together, at least concentrate on problem 11, ladies and gentlemen. And Laura, I agree with you. FSCJ police should also be informed. Did anybody inform FSCJ police?
I work in IT. There's usually like a abuse email to send it to. I'm sure we can find it. But
Okay.
I guess you can call the police. I don't know.
Yeah. Okay. Let me back up and read some of these things, because now I'm really concerned because of what you just told me. In fact, I am really ticked off. I'll see. Here, all right, we managed that one. All right, down here we got, oh my gosh.
I can just explain it to you after class. It's not. It's just something they sent to all FSCJ emails or whatever list they had. It's not like pertaining to us specifically.
Okay, thank you, Laura. I'm beginning to see now what you mean. In fact, I don't even know that my dean knows that, Laura. So I will certainly share that with her. I have been in contact with her and the tech team over the weekend, and you don't work during the weekends. Well, I do, and it was a major concern. Couldn't figure out what was going on. Yes. But yeah, it's Physing. Don't click the link. Yes, you're right. Is there any way where you could just respond back to email saying, yes, I have tried my best, but being absorbed in the mess, I got away from that trying to just solve it. I think the last couple of days, maybe I wrote received and then went on, but certainly not for the last week. Had trouble getting to everybody. That way it helps us know, okay, yeah. There at the beginning, when we weren't interfered with, I think a lot of you remember I did say received, and then when you had to resend me something, I try to say thank you. Yeah, I'm here. Okay, good. And then with that first homework assignment, which I think got sent way off to clutter or something, please study problem 11. However, don't memorize problem 11. My online tests are designed to put together information whose method of thinking and analyzing data can be found in the homework and the lecture material, which means you don't want to try to memorize anything we're doing. Learn how to use your resources and figure out the problem. I'll give you an example, although I think I even mentioned this. I mentioned that in unit conversion, some of the standard unit conversion are based on using one significant figure. How many of you remember the example I have of going 60 miles an hour? Well, a problem on the test, not quiz, might be a computation that requires answers in meters per second. And I might ask that you express that in terms of one significant figure in miles per hour, which means then you'd have to work a problem and then do the conversion. Does everybody see how chapter 1 really can just be a part of something? Hello?
Yes, ma'am.
You mean how
Okay.
it's one of the methods used further in like all physics? It's not
I'm not-
really like an application by itself?
Well,
Is that what you mean by
the example I gave you was really an example we used for physics, not necessarily. You don't want to use one significant figure in medicine, folks. You want to get as many significant figures as you can. That's why, they have cubic centimeters of stuff instead of liters. They're talking about small amounts in medicine. So don't use the macroscopic measurements of physics in something like microbiology, for instance. There should be some report email to forward it to. Let's use your standard. I'm not quite sure what you mean, report email, but okay, yeah, okay, thank you. I called them earlier and forwarded earlier.
Oh, I was just talking to Laura. Excuse me.
Oh, okay.
Thanks, guys.
Actually,
All the info.
ladies and gentlemen, you reassured me because I really thought about the last week to 10 days that Canvas was really all messed up. And I was at my wit's end as to how then we could conduct this class. But as I probably won't have time to get back with the dean, but as soon as she's at a different campus. She's at Kent campus and may not be aware of the problem that has been apparently solved, because I did get to quiz 3, and in fact, while you were doing the lab, remember I said I had graded it, and so far everybody had a 3. How many of you remember me saying that? which means it had been apparently in a resolution situation by Thursday of last week. Okay. I guess that instead of waiting and taking time at the end of class to talk about the lab, I'm going to do it now, if you don't mind, ladies and gentlemen, because I'm afraid we might run out of presentation time today after getting all this discussion. The lab report.
Professor, real quick, I'm sorry.
Go ahead.
And this is, I should have known this, I know, but I checked the syllabus. I couldn't find it. Do you accept any late work?
No, sir.
Okay.
Online. Well, I have hinted at something because of what has happened. You can backtrack to Chapter 1, and you may also submit Chapter 2 because I believe some of it was affected then. I'm not guaranteed, but if it were running on the 2nd of June, I'm not quite sure when you got the pricing. Let me back up here, see if this is listed here. Yeah, it happened after June 2nd. I'm going to say go ahead and resubmit Chapter 2 if you don't have a grade for Chapter 2. That was the homework that was due on the 8th, and that would probably be the last thing that's affected. Of course, 3 and first part of 4.
Chapter 2 still?
Pardon?
You said we may still submit Chapter 2?
Yes, sir. I checked when the phasing occurred. It happened to occur on the day that chapter was due, which means some of you that were responding that got that probably went to spam. And I have recorded the people who I have homework from, and I was very disappointed in the numbers, so I haven't had a chance to go through all of the spam yet, but I've been sending the spam back to me as just a marker. Please feel free to send me Chapter 1 and 2 if you haven't done so yet. What a mess. Luckily, your test is not until, a week and a half away. It gives you a little bit of time, folks. Yeah. In the lab, in fact, I tell you, I'm going to get out of conference for a minute and yet leave it on because I'm going to go and lift the page, hopefully, and put it on the screen that gives you some general information about the lab and lab analyses. So if you would all like to, oh my gosh, if you would like to maybe take a 5 or 10 minute break, let's say 10 minutes, I'm going to lift that page out and replace this lesson 4A, which is up here. It's really the beginning of this discussion 4 that I was going to go over, but I'm going to come back and add a conference page so that we can look at the requirements for a lab. If you don't mind, everybody, can I see you back here in about 10 minutes? It's, it's 2:03, and let's say 2:10 if you don't mind. And have I got a quick question or two before I go searching for the page and lift it out to here? Okay, everybody, see you back in about 7 minutes, 2:10. Thank you very much, folks. Oh, what a life. Yeah, I knew something was wrong. Something had to be wrong. Whew. Finally. Okay, ladies and gentlemen, do I have everybody back? I'm a little late, but I'm going to go ahead and move to full screen if you don't mind, ladies and gentlemen. Do I have everybody, or most everybody? Okay, thank you. I'm going to move to full screen because I want to emphasize certain points that we will use. We're certainly not going to have lab reports, but part of the lab report is analysis, and that's what I'm after, ladies and gentlemen. So I'm going to move to full screen, and I hope everybody can see this. It is multicolor. The title is Physics Laboratory General Information. Give you a few minutes to kind of orient yourself. Generally, the lab, come on, let's keep it. Full screen. Here we go. Wow. Beautiful. It covers the whole screen, ladies and gentlemen. I don't know if you can see it too. Generally, the face-to-face lab room is C211. I don't know if any of you have ever had a class in there. But notice it says that each student will submit his or her own written. And I'm going to change the word report here to analysis because you're working as an individual. The lab report is due on the specified date given on the lesson outline. And in your case, that lesson outline is embedded in the calendar. But a good rule of thumb is it is due the next lab that you'll be doing. In other words, lab 2 will have, on that date, lab 1 will be due by midnight that night, which is usually about a week separating the two. Notice that late reports are not accepted. One reason why in most science classes late work is not accepted is so that we can get the grades out to students, and then if somebody is a week late, then they have all of the right techniques and methods, and that's not fair to you that submitted it on time. Obviously, it should be legible, concise. In fact, if it's too wordy, that is not scientific. you know, scientists are sometimes to the point, maybe even being blunt to the point. And please use an 8.5 by 11 sheet of paper. Notice that scientific work is usually in black, but dark blue or black is quite acceptable. Oh, my computer does not want to manage full screen. Let me try this. Back here and then back. All right, well, we'll try one more. Well, all right, we'll just go to full screen there. I'm not quite sure if you got this view or the larger view a minute ago. The lab report should include, however, I amended this for lab analysis only. And the lab analysis only should include the following sections only. And one of those sections is a data sheet. And notice that literally every lab that you will be doing, now I hope everybody can see me doing some crude circling of something. Can someone say yes or no to that? Hello?
Yes, ma'am.
You are now unmuted.
Okay, thank you. In fact, I'm sure that everybody's either got their microphone on or their phone on, and I think I heard two voices. Thank you, and just to make sure that I'm communicating here. So this implies, when you say data sheet, that you just don't do one trial or one run or click the button once and watch something move in virtual lab. It implies that you're going to change at least one variable of whatever's going on. In the case of your particular lab, I sort of hinted while the lab was going on that one thing you want to change is the length of the glider. And a few had trouble getting to, of course, the links and then clicking on, and the effect that that had on the variable. The other variables will change, but the cause of that change, not the effect, is what you're looking at, and the cause was to change the length of the glider. And then if you change the length of the glider at least 2 more times, and I suggested anywhere from 3 to 5 changes, you would have a data table for each one of those glider lengths. Now, I know that the velocity through the first gate and the second will change, but that's an effect of your change. And so, of course, if you elected to use only the 3 of your 5 runs, and 3 is pretty much the minimum, you would have 3 data tables with different readings for average velocities in the first photo gate and the second. And then notice that they do the calculation for you, but that's their calculations. What I want you to do is calculate from the data of the runs the average velocity and follow through with their analysis in order to find the acceleration. And I hope most of you realize that you had to use one or more of the kinematic equations for linear motion, of course, along the air track that they were using. And that, of course, would be assume the motion to the right is positive x-axis or the positive I unit vector notation. It's the collected data that you completed during experimentation, or it would be the table that they have developed for the results of the run, and notice they had the time to begin and the time to end for each of the photogate timers. And of course, it's provided with each experiment usually, and at this level, about every third or fourth lab, you will generate your own data table. Unfortunately, they kind of hinted at how the data table would be in the virtual lab. And notice that I said your data table should be initial before you leave the lab. Well, we're not in a lab room, so that's not going to happen. Final data submitted should be entered in ink with proper units at all times. The few of you that have sent me some samples indeed have the ink down pat, but some of you are not including the units because you're making the assumption that everybody's looking at maybe the data table that was in the virtual lab. Just be careful. Make sure that every number you give has a unit by it, or it's not scientifically viable. And of course, you may have to use more than one data sheet, and that would be your construction. The second item, which must be included, would be sample calculations. Those sample calculations that will be needed to complete the data. In other words, calculating the average velocity. And you had to calculate the average velocity for, if you have 3 data tables, at least 3 times. And you don't have to include all 3 calculations, because if you have one calculation for average velocity, it should be applicable to any values you would put in the equation. Now, here's an example of how scientific equation work to be. Namely, one, notice that the equation that you're using should be stated, and that is applicable to homework as well. A lot of your homework is missing the equation needed to justify the next step, which was a substitution of data. And a lot of you just said, well, she knows what the data is, and so she'll know what all those numbers are. Yes, but what happens if you're reporting that to somebody that is not familiar with the homework problem? So every problem you do in homework should have at least 3 parts. An equation in symbol form, and please, acceptable symbol format. Don't invent your own symbols, please. Then substitute your data with units, and the final answer. Now, this is a minimum of 3 steps. In this particular course, sometimes you'll find that you'll need a 4th or 5th step in order to group your values and justify your units. And sometimes you will have even another equation that you'll have to use to eventually get to the final answer. The final answer, please justify your units. At this level, usually the units just fall in place, like average velocity would be a meter per second, and that kind of follows with taking a length and dividing by time. So, and then the final answer. Final answer for lab work, if you can get 3 significant figures. I think the length of those gliders were in centimeters, so you may only have 2 significant figures. Remember, it's the least accurate of the numbers that you are multiplying by. Just be careful, or dividing. Be careful. When your calculator gives you a value of 3.257689110, 10, obviously it is running it out to as many places that your screen has. In writing the number that your calculator gave you, don't use more than 3 numerals. You're misleading the people that are reading your work into believing that you may be more accurate than you really are. And you don't want to mislead anybody. If you really want to go to the 4th significant figure and round off at the end, you realize if you're multiplying 2 numbers that are 4 significant figures, you may be increasing the number by at least maybe the 1,000th place or the 1st place if you're expressing something in thousands. So be careful. I would stick with the 3. And I mentioned that on my test, I generally will have answers only to 2 significant figures, which means your 3rd is your working test or homework or lab. Might show a 3rd, but I want to make sure that the methods of rounding that you use would yield a similar 2 significant figure answer. And there are various rules for rounding off, most of you know, and you certainly may apply them. So at least how many steps in working problems in science, ladies and gentlemen, do I have an answer? At least how many steps? Thank you. I only have one person that agrees with that.
It just takes
At
10
least,
seconds to get unmuted, 3.
pardon?
It takes me a minute to get unmuted so I can actually respond to you, but the answer's 3.
Well, I appreciate you becoming unmuted, and I understand why you want to mute. Thank you. So I know I've got at least 2 people that hear me. And I know there's some also on microphone for the same reason. They want to be able to hear me without distraction. And I can appreciate that, ladies and gentlemen. In fact, we all have different learning styles. Okay, the last part of an analysis grade, and notice sample calculations are valued sometimes as much as half of the lab analysis grade of 10 points. I hope some of you are wondering about this 0 right here. How can you have a lab and have no sample calculations? These are labs usually by observance when we're studying optics, which is in Physics 2 with calculus. So I could almost say that your sample calculations will always be greater than 0, at least 1 point to as many as half of your lab analysis grade. And the data sheet, of course, certainly is valued at least at 1 and could be as much as 3 or 30% of your lab grade. Now, the last thing is conclusions. And conclusions are now, this is an old form, but conclusions now are worth 4 points at least. So this should be a 4 here and not a 2. The only form I could find was this one. Now, is anybody curious as to why I have changed the 2 to a 4, ladies and gentlemen? Is anybody curious? Uh-oh. Yes, sir. And I'm trying to get you to pay closer attention to actually what you're doing. And I added something that does not appear on here, and that was, in fact, if you want to put it in a separate section because it's not conclusion, but since it is a virtual lab, and the class I had last semester had virtual labs, but we were doing Physics 2, not Physics 1. And I am interested in any suggestions you might have with respect to the limitations of the virtual lab that you had just completed, and any suggestions. And that is a little bit of the part of what's already here, but I want it a little more. And that's really not part of a scientific lab. It's more educational, unfortunately. And if you want to separate it out from your lab analysis, I'll know why. It's not scientific. It's educational. I'm not interested in educational results and a lab analysis. Okay. Conclusion should be a concise statement or statements which relates what was learned or verified during experimentation. Now, this means the scientific learning, nothing to do with educational. You want to separate that out. If any of you want to go into education, you'll be thinking about lab experiments in that light. But most of you want to be engineers, go into medicine, biomedical engineering. They're not going to be interested in your attitude or your viewpoint of what's going on. They want the scientific results and then separate it from it, your individual ideas of improvement, for instance, etc. It should include, where appropriate, an accurate interpretation of any graph. In your first lab, there were no graphs, so you would not want to do number 1. Please don't say there were no graphs in this lab. No, just no. For our first virtual lab, no. Now, notice that number 2 says data trends which should have been observed by the student. And I've sort of hinted at one of the trend that you should have noticed. If you have changed the length of that glider at least twice, you should have 3 data tables. And I'm going to give you a hint here. If the glider's length became shorter, what happened to the average velocity? If you want to talk about through the first gate as well as the second gate, what happened to the acceleration? There are 3 variables there that would be dependent on the length of the glider. and hopefully from your 3 data tables, where the only thing you changed was the length of the glider, what effect did it have on the experimentation? Ladies and gentlemen, I'm going to let you think about that for a minute. My dog has found her way into where I am working. I'm going to take her back to where she'll be quiet. I'll be right back. Come on. Come on. I'm back. Somebody hear me? Hello?
Yes, we can hear you.
Thank you. I apologize. I tell you, this course has had a bad start. I'm going to try to make up for it. She's now where she should be. Smart dog to work her way. I thought the doors were shut firmly. I think I was talking about any trends that you may want to observe, and you want to base your trends on what you changed. For instance, you might say, when the glider was shorter, it was found that the velocity through the average velocity through the first Protogate timer did not change, went up, went down, and the same thing for part 2, or Protogate timer 2. And see if that follows through with all of the 3. What happens if the length is, instead of shorter, greater or something? Okay. The third thing you should address, particularly in this virtual lab, would be the second thing, the effect that the limitations of the experiment with respect to perhaps the equipment accuracy, the reliability of the measurements, which I don't know if any of you have noticed, but sometimes when you try to get an exact length of maybe the glider at maybe 8 centimeters, it just doesn't go. It gives you the 8.1 or something, and that's not what you wanted. You wanted an even number like 12.0. And so it does have limitations. You may or may not have noticed that. That would not affect the accuracy, but it's not what you really wanted to use as a measurement. What it has on the measurements made during the Protogate timer shutting on and off, that would be more of an observation that you saw. Then the third thing is some of the causes of error. And, you know, during a virtual lab, if the electricity were to blink or something, I have never had that happen to see if it affected the virtual lab, because you're pulling down a virtual lab out of wireless communication, and it may not have been affected by any kind of weather or atmosphere. So it's a little hard to pick out what the errors perhaps could be. However, if you find in the cause effect of changing the length of the glider that something appears not to be the trend that it should be based on kinematic equations, you might want to rerun that, and in so doing, you might conclude that after a rerun, the values fell into the proper trend that was evident from the other 2 data tables. And then the last thing, the facts. And here, because we haven't written a theory, you'd have to go back to the equations you were using, which were the kinematic. The facts from theory as verified by your experimentation. One fact that you should have concluded, in fact, it was in the quiz material that I had for, I believe it was the second quiz. And what limitation do we have on the use of kinematic equations? Does anybody remember what the answer to that was, especially if you made a 3 out of 3? the limitation that we have on using kinematic equations is, somebody have an answer to that? Somebody just want to respond. Hello? Anybody?
Was it constant acceleration?
He's absolutely correct. With the use of your kinematic equations, you have understood that the acceleration along that, between the photogate timers, along that air track, has been presumed to be constant. We have no verification for that. They didn't even discuss theory. But since it was a straight line motion, there was, the air track, of course, is being assumed to be frictionless. In theory, in virtual labs, it's almost ideal situation. However, if we were in the laboratory using the air tracks that we have in that class and the photogate timers that we have in that class, which incidentally can read to the nearest 10,000ths of a second, far beyond any three significant figures that we want to use. But we would find later in the course that our air tracks in the laboratory indeed have a coefficient of kinetic friction. It is extremely small, but in the techniques we'll be using, we can even collect some of the data that we had prior to our study of, let's say, momentum, which is chapter 9, and we can backtrack and determine the coefficient of friction at least to 2-3 significant figures of every air track in our lab at South Campus. And so we can realize that even the air tracks are not totally frictionless in real life, in a real laboratory where we were working with equipment instead of doing a virtual lab. So I'll leave you to look at some of the limitations, some of the suggestions you might have, and if you'll place those maybe as comments. They're not conclusions, but they're comments, and they're much appreciated. Notice that this, if it were a complete laboratory, would be worth 15 points. Since we're not doing the first and second pages, which is objective, theory, equipment, which is a little redundant question because it's listed for you in a face-to-face lab, and procedure, those first 4 concepts are parts to the lab report are omitted here. So we are looking at only a 10-point lab analysis. I hope that this will help you formulate your lab analysis for the second lab. The second lab will be on projectile motion. And ladies and gentlemen, I'd like to make this statement because you'll probably come to the same conclusion. But the projectile motion lab is more like a game than a lab. And the reason I included it is so you realize what I consider just a game, video game, from an actual lab report. I am not interested in you doing the projectile motion lab and hitting the target, so-called. I'm interested in you looking at changing the variables of that fired projectile. I think it starts from the top of a building. If you were to take half the height of the building, that would be the variable that you change. Or if you go take the building down to just the flat surface, that would be certainly 3 measurements of height from 0, half the height of the building, and look at the projection from those 3 positions. Everybody see what the point is I'm making there? You can make a virtual game a little more lab-like. Does somebody want to agree with that?
Yeah.
Yes. 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 Trends, limitations, possible errors and suggestions. The facts, well, we had no theory. so you might in your conclusion say, based on the fact that if you're dealing with your kinematic equations, which apply only when the acceleration is constant, that was a given understanding for this lab. That would be a very positive statement in conclusion that tells you why we analyzed it the way we did. And that, of course, is one reason why I asked that question on the quiz, is I want to establish that firmly as a limitation. And we'll see its application once we begin to review the first section of Chapter 4, which I'm just about getting ready to do. Would everybody agree? Whoop. I think I had a young lady that was going to make a comment. Yes?
They asked first, if so.
Okay. I'm
Oh.
going to get... Hello?
Sorry. Yeah, I was just wondering if you could, are you saying that we're able to make a video game for the lab?
No, I said that there is a lab that appears to be more like a virtual game, and that will be your next lab. And the reason I selected it is I hope you realize that it was more game-like, trying to hit a target on the ground. I'm not interested in you hitting the target on the ground. I want you to analyze the data. So ignore this hitting the target from on the ground. And I suggested that you change at least the location of the firing position. I think they start you with firing it at an angle to the horizontal at the top of a building. Maybe
Where can I
fire
find
it.
the file that has this info, like this physics lab general info file? How do I find that? I wanna
Would you
download
speak a little loud? Speak
Yes,
a little
ma'am.
louder,
Sorry.
please.
Okay, I want to know how I can find this physics laboratory general information document that you have pulled up right now. That we all see.
Yes, it should be in general information. Let's see, it's going to be after how your grade was determined, how papers should be turned in, which I hope you've read, and then below how to submit work using emails. And then below that, I believe there is general information for the lab. In fact, that page should look almost like this page, but it will talk about lab analysis. I tried to lift it in the time we took a break, and it won't lift out of it.
I see it says is unit conversion important, and then it jumps down to this arcane coding that I don't really understand. Ansto P9 10th edition.
Okay, I'll have to look at, yeah, I'll have to look at it and get back with everybody as a general statement, because it should be there. Of course, I've already found 2 files that apparently switched off. That was interesting. I'll get back with you and see if I can resolve that, because you should have the updated version of this page, because it was uplifted to both of my classes. Don't know what happened, but we'll see. Thank you. I'm going to go ahead and get off of this and get back then to the lesson 4A, I believe it was. Okay, here we go. Right. Okay, let's get back to lift this up. Okay, 4A. Here we are. Here. Well, ladies and gentlemen, remember, I can't see your comments when I have full page. So I'm going to go back and read some of these while you're looking at lesson 4A. Okay, thanks. Oh, good. A lot of you agree. Okay. Okay, folks, I'm not quite sure what some of your comments are, but per instruction, everybody said to at least change the length of the glider, and a few of you were asking that in conference during the lab. So I know at least several of you actually changed the length. Or since the lab is not due until the second lab, a lot of you may want to go back and rechange some of those variables now that you've got some data. Okay, I'm glad somebody's speechless. I like to think physics in some ways is speechless.
Are there separate times for lab and lecture meetings?
Oh, yes, the lab generally should average about, well, the state only requires that we do 7 labs. And then the rest of the
time of the week, like instead of getting
Pardon?
on 1 to 4:20 Tuesdays and Thursdays for lectures, do we need to get on at another time of the week for labs?
No. Well, you can access the course anytime you want to work on anything, but we have to document that we were in contact during your class hours. And of course, that is sort of an attendance. Hello?
Yes, ma'am, I'm here.
Okay, thank you. And that's why a lot of instructors will give you quizzes the first 15 minutes of the scheduled class time. That is to document your attendance. And then, to be absolutely frank with you, if you don't go to conference, then I don't know what you'll do, because in conference it tells me how many people are with me. And right now everybody is in attendance. So, and in fact, if you go off conference, I'll know you're gone. There's a reason for that. There's a state law.
I'm ashamed.
Are you familiar with the state requirements if you're financial aid, if you're a veteran, or whatever?
Yes,
Now,
ma'am, I'm one of those things.
now, ladies and gentlemen, I'll be honest with you. There are some faculty that, although they're supposed to meet 1 day for lecture, and the other for lab, and it doesn't make any difference which day was lab, depends on when you're scheduled, usually for the face-to-face classroom lab. Here, we can have labs on Tuesday or Thursday. Now, I'll tell you, when I figured out, like we did the first lab, that if I stayed in conference, and if everybody stayed in conference, they could go ahead and exit Canvas. They're still in conference. And they could do a lab and talk to me while they're doing the lab. And I like that, because I don't like sending students to do a virtual lab that has no theory. I really don't like that. And a number of you, I believe I recorded 6 of you, asked me specific questions about procedure during the lab and how to find or how to change the length of the glider. And that's why you need to stay in conference, especially during a lab. If, however, you go ahead and exit the conference and do the lab some other day, I won't be in conference during that day. You'd have to send me an email, and I may be driving, I may be grocery shopping, I may do anything, folks. I may even be trying to figure out what happened to your emails and homework, which had been sponged up a lot of my time. But if you want me to be available, try to set aside the lab conference days for lab, and then at least learn from it. And then I suggest that since it's not due until the next lab, which is a week, 10 days away, from what you learn that day during lab with conference, I hope that you'll be able to exceed, be more successful while doing the lab without conference. Does that help a little bit? And I know some professors just give you the whole week off or something to do your research or write your paper. In science, it doesn't work that way. We have to have confidence that you are performing the lab. everybody's lab is going to be different. The run times are different. Ladies and gentlemen, if you copy somebody, make sure it's not verbatim. In the other class, I've already caught 2 people that copied one another's homework. I'm not going to tell you how I knew it, but what I did was I took the homework points and I divided by 2. Well, if your homework points is 10, and I divide, well, they made an 8, divide it by 2, each one got a 4. That's failing for that particular homework. I think maybe you see the point now, ladies and gentlemen. Nope. Are we there? Yeah, thank you. Oh, somebody did. They found it in files. Madison, it's lab general information 15 point document. It's in files. Thank you, thank you, thank you.
Yeah, of course.
I knew I put it in there. I just couldn't find it. Mentally, in the first lab, it doesn't let us change any of the variables. It just randomly does that. John, in the first lab, you can go to the measurement of the glider. They kind of like to use a centimeter rule against it, and you can move that so you'll change in the length of the glider. Okay. Oh, thank you. Well, thank you, Clayton. If you teach, you better make sure it's not obvious, at least to me. I've been teaching so long. Well, I'll tell you what these 2 people did. They sent me the same photocopy of the homework in a handwritten document. No 2 people write the same. It was so obvious. Yeah. And they figured I just wasn't going to look at it. Well, that's all. I am confined to home. I have somebody buying my groceries, and I have to have something to do, or I'll start counting raindrops, and I don't want to do that.
You know, there are programs that will read a PDF and then just rewrite all the handwritten stuff in like somebody else's writing. And it's just a shame that like they didn't even do that, you know?
Yeah. Labs are so individual, but I don't mind you working with someone, but don't do it on a test. Again, it might happen, but if I detect it, folks, the whole test grade is going to be divided by 2, and if I find that 3 are working together, I'm going to take the test grade and divide it by 3, and that's not going to pass. So be careful. Yes, but I encourage working with classmates. That's almost like being in a real classroom. And when we have conferences for labs, that's what you're doing. You're helping one another. I like that. I can't think of any of the career fields that many of you mentioned. Biomedical engineering, mechanical engineers, electrical engineers. All of you have got to learn. Yes, all of you have got to work with people. And this online business is not cutting it. When you get an upper division, you may be given online material to study, but your labs will be extremely important because you'll do project work, you'll have a director. In your senior year, you'll probably go to being an intern somewhere and learn to get along with people, learn to present your ideas and your case to people and defend it. Allow other people to talk about what you've suggested, the improvements, and own and own and own. Engineering and biomedical, all the other kind of scientific fields are not a lone scientist working in their shed in the backyard anymore. It's not going to work. Okay. I'm going to go to a full screen then. This is going to be a quick overview of what we were talking about in our discussion of Chapter 4. Oh, here we go. Bigger screen. I can even go further now. Let's go with it. Let me see if I can keep this It is a bit of an introduction. If you did study the material of sections 4.1 and 4.2, it talked about having an initial velocity and acceleration in unit vector notation. I'm going to have to go back to a smaller screen. And then it really talks about the fact that it appears that the acceleration here is in 3 directions. A little hard then for that to happen. On the quiz, I didn't use 3 seconds, I used 4. The equation that is usually used is the defining equation that you see right here. If you remember, this equation was developed through an analysis of graphic motion, and just kind of substituting values in that equation. And notice I have the equation, which is step 1. I have step 2 here, although it's in IJK notation. And I'm collecting the unknown terms to the right. In other words, I didn't know all of this. And then notice that I was equating all of the IS. That goes with that, and it goes with that one, then it goes with that one. And of course, that would be what you see down here. You may have had some homework problems that related to something similar to this. And then, of course, solving each one of these, noticing that I is a common factor here, although it's direction. But down here, I've implied that this would be the x direction velocity. Okay, little review there. Substituting those values into any of the other equations down here. Since there is no quadratic factors here, you could substitute it here or here. This you could not use yet until we learned what we mean by vector multiplication. And I mentioned that. Okay, today's lesson, projectile motion. Since you've had an introductory course in physics, even though it may have been physics in high school, one of the topics that is studied extensively is usually projectile motion. And I'm sure a lot of you remember studying projectile motion. An example of what you found during that time was like your sample problems in projectile motion. An object can be thrown with a velocity of, let's say, 50 meters per second. A lot of books call that the initial velocity. Some of it say its velocity at time t equals 0. And they usually use a convenient angle like 53 degrees, 60 degrees, maybe 45. In order to start you out, because those would be the 3, 4, 5, 30, 60, and right triangle with 45, 45 sides. Then they will ask you the time to reach the peak. They may say, what is the velocity at the peak? Oh my gosh, you don't even have to work that problem. The distance to the maximum height it reaches, time to return to the initial height, the vertical displacement on return to the original height, horizontal displacement at the position in E, the velocity at the position E, which would be at the very end of its flight, just before it hits the ground, because it is no longer in free fall. It has now got 2 forces, gravity, of course, and the ground pushing back. So that is no longer part of projectile motion. Then particular positions after a given period of time, a particular velocity after a given period of time. Now, ladies and gentlemen, I can make a test just out of these 10 questions, 9 or 10 questions. I think you'll agree. Some are evident. The velocity at the top can be answered 2 ways. If it's truly a projectile motion and it goes through the path of a parabola, you will find that its horizontal velocity remains constant. Well, what would be its vertical velocity? Well, it's at the peak of the direction of free fall, and the velocity at the peak of a free fall object is 0. So you could answer that by saying the velocity at the peak is only in the x direction and is the same horizontal velocity that you threw it with, or the horizontal component of the velocity that you threw at 53 degrees. In other words, you have to find the x component here, just like chapter 3. You can answer that without doing any work. Well, let's just look at somehow you could get individual answers to this. One method for solving projectile problems is to separate the horizontal, or X or IS, unit vector notation from the vertical, which is the Y or the JS unit vector notation. Notice that you can almost draw a vertical line through these two directions, where the time of flight in the X direction is exactly equal to the time of flight in the Y direction. Then find the individual component in that direction. I think from inspection, if you were to draw a diagram, incidentally, diagrams are required for almost all problems of motion. Some of you need to go back and think about diagrams, particularly in your Chapter 2 homework. Notice that I've calculated the value in a 3, 4, 5 triangle. I know that the leg that whose cosine is related to it is going to be the 3, 4, 5. This is the 3 side, and it's in 10, so it'd be 30 meters per second. And I remind myself that there was no acceleration in the X direction. As you recall, the only acceleration, once that projectile has left your hand and is going through a parabolic trajectory, which means path, that the only acceleration occurring is the acceleration due to gravity, which is in the JS direction. There is no X component or IS. To analyze the vertical component, that follows. This is the foreleg of a 3, 4, 5 triangle. And notice I recognize that the acceleration due to gravity is acting only in the Y direction. This is also imprinted on a lot of diagrams in Chapter 4 and acts vertically down. And notice that your text, as well as the methods of science, generally agree that from the top of the page down, or from a height above the earth down, the direction is negative, which means the minus J direction, or down. Now, if you go to the time to get to the peak, well, up and down is what's happening. Although it may be a parabolic motion, it is still going up and down in the Y direction. So I picked the equation, actually, that you should have used with the quiz. And notice that I substitute the values for the initial velocity, final velocity, the acceleration, and I can find then the time to the peak. And notice that the velocity in the Y direction at the peak, which would be its final, was the 0 that I mentioned. The initial velocity is 40, but notice the negative sign in the equation must be used. And then, of course, with acceleration due to gravity, also negative, I end up with positive time. Now, if I ended up with negative time, would you agree I knew that a sign was wrong somewhere? Do I have a yes from anybody? Thank you. Good. Actually, this data here, I hate to tell you where I got this data. This was actually a problem that I worked when I first developed this particular, format. And it was in 1990, I think it was 97. That's a long time ago. That's why my PowerPoints are rather static. They're rudimentary, but at least it gives me time to get from one place to the other. Okay. The velocity at the peak, interesting enough, notice that the initial velocity would be in the horizontal only, and I already mentioned this, it's something that we would know would be true, since no matter where in the parabolic motion, the horizontal component at all times will be what it was initially, because there is no, we always know there's no friction or draft or any kind of retarding of motion. The distance to the peak, here's where you would utilize the effect that the initial velocity in the Y, and you may go back and usually with assurance that the time, wait a minute, pardon me, ladies and gentlemen, if you'll review the page, I've got a dog that tends to again. Oh, I thought we had her. I'm back. Seems like today is a day that I apologize. I regret. You know. All right. Is everybody with me?
Yes, ma'am.
Just a minute.
Yes, ma'am.
I apologize again. I might be getting good at that. Can everyone hear me?
Yes.
Yes. I think that might be my neighbor's dog on this side of the house. Can you all hear me over that?
Yes, ma'am.
Thank you. I appreciate your effort. Okay. Time to reach the original height, which would really mean that your change in y, which could be this value here, but it's more than just to the peak. It's to the peak and back again. The change in y in part D here would be 0 because your displacement has come back to its original position. So it would really mean that you went the distance, final, and then you came back to your original position. The time of flight, though, is easier to determine since there's no retarding forces or drag or friction. It would just be twice the time to the peak. And here I've used 3 significant figures, but actually on a quiz or something, this could end up being 8.2. Would everybody agree? Yeah, you see how that works. And notice I didn't go out further than 3 significant figures. Okay. And here was the discussion. The displacement is equal to 0 here, and yet, if I asked for the distance, I would have actually the linear distance that I traveled as if I weren't going back to where if I said what distance did I travel, it would be the distance up and the distance down. Displacement means with regard to direction. This would be positive and that negative, so this is what would happen if I'm talking about displacement. Now, excuse me, the reason for the displacement being equal to 0, and this is also embedded in the kinematic equations. The kinematic equations deals with instantaneous values because they are values that occurred at a single point in time. Notice the AT minus something, or even if the initial time was 1 second. You're really talking about the constant acceleration during that time interval. A question F would be, what is the horizontal displacement in, of course, the x direction? This also could be considered the range. If you're dealing with a projectile that started from the ground, had the parabolic motion, and came back to the ground, notice I use the total time of flight. I am using the initial horizontal velocity, which never changed, and of course 245. Notice that there is an equation, a substitution of data, and an answer, and since the seconds go out, meter is quite obvious. Due to symmetry, the velocity at a point, say E for instance, would be minus 50 meters per second at minus 53 degrees. That means it's coming back down. This can be verified by using the x and the y values for v and a particular equation here that shows you both the horizontal and vertical. Now, another way of looking at this expression is x and y are 90 degrees to one another. So we are dealing with Pythagorean theorem at this point. In other words, I know that the speed or the magnitude of the velocity would equal to, and this equation is fairly important, ladies and gentlemen, for determining the velocity anywhere in the motion. When it begins, any time during the path, at the peak, anywhere between the peak and the final landing position, is take the x component, that's of x, and square it, plus the y component. Actually, I think this is also in your text because they emphasize that these components, by definition, are at 90 degrees to one another when you're dealing with the motion in a plane, or even in 3 dimension. If there was a 3rd dimension here, this would be the velocity sub z squared. Then determining h would be a position 10 seconds into the motion, and this equation will be used. Whoops. Question 10 seconds into the motion in the in the y direction where this is equal to 0. That is constant motion. Okay, h. And these are the values we're using for h, and we find that, notice that I have it bold-faced. Would everybody agree that that implies I'm looking for a direction instead of just a distance? And yes, the big clue there is if there's not a multiple choice selection, it's a look at the meaning of the problem. And if you just want a distance or if you want a speed, then you're not going to have those variables bold-faced in your text. They will not have an arrow over them, and they may indeed even ask for what is the magnitude only. And they won't say magnitude of the velocity because that's a little redundant. The velocity, average velocity would be a better way of saying that, or just the speed during that interval or the midpoint of the interval. I 10 seconds into the motion, this is constant, and notice that 10 seconds into the motion that the vertical velocity has started on its way down. If you'll look at that very carefully. The magnitude of the velocity 10 seconds into the motion, and we've got, and then take the square root. Yeah, I've already given you this equation, but take the square root of both sides, and you find it to be. Now, this is the magnitude, which can only be found using this equation, obviously, dealing with magnitude, because you can't square an I, which is the unit vector notation. However, its direction is found by taking the tangent of the angle, or the angle is the arctan, and notice that is just like slope. It is the y value, or whatever you're dealing with. In this case, it's a v sub y value divided by a v sub x. Now, this should be bold-faced, which means v sub y is negative. Notice the negative sign. If I take the arctan of this, a lot of times it only gives you 58 degrees, and you have to look at the problem to know from your diagram or from this discussion that it is not going up, it's coming down, which means this angle is in the 4th quadrant or below the x-axis, positive x-axis. But everybody agree with that? Good. Okay. Yeah, now here's something that is emphasized by the text chapter 4 that I recall, and it's also emphasized in your book.
Professor,
Other ways to determine. Yes.
That's the northern
Question?
quadrant because 0 is north, right?
Pardon?
0 degrees is north, right?
No.
East.
You're talking military now. North is toward the top of the page, but 0 degrees goes back to your Cartesian coordinate system, and the positive x direction is 0 degrees.
Okay.
Then the north that you're talking about would be 90 degrees. Remember when we were doing vectors and their components? The positive x-axis was the orientation of increasing angle as it moved toward the positive y-axis. they have a discussion of that at the beginning of Chapter 3 with respect to your Cartesian coordinate system. You may want to reread that. Those of you that have been in the military, you may even want to remind yourself that if you have a notebook paper, just put an arrow toward the top, that's north 90 degrees, an arrow toward the right of your page, that's obviously positive X, but it's also 0 degrees, and just use that as a reference until you get used to that method of science. The last little paragraph here is other ways of determining answers A through I would be to use one or more of the equations listed in your text for projectile motion. These equations give the peak height, the range, where the range is the horizontal distance when the vertical displacement is 0. It should be noted that the angle which gives the maximum range for a given initial velocity is 45 degrees. Some of you may want to set in your projectile motion virtual lab one of your readings to be 45 degrees and verify this with respect to an initial velocity. So I'm giving you a little bit of a clue here as to what you may want to add to your second lab. This right here. Lab related. L-A-B. Okay. This concludes this lesson about projectile motion.
Ms. Dewberry?
There is, yes ma'am.
I looked literally all over for this file on Canvas, and I can't find it anywhere. Is there any way that you can post it or email it to me?
It is posted. Let's go back and find the title. I believe
because I've literally gone through like every file, and I cannot find this.
All right. Yeah. Oh, well, good. That's the next file.
4B is way at the bottom.
And I'm having, pardon?
4B is way at the bottom for some reason. Some students might have missed those pages.
Yes, yeah, I fed all of these before the problem we had with Canvas. Oh my.
But yeah, is there any way that you could like email this to me or post it somewhere? Because like I cannot find it, and I went through everything.
Well, I'll tell you. Let me exit it, and I'll go back and verify what you said, because you know what may have happened? It's unpublished, and it should be published. But I won't guarantee that's correct after everything that's happened to me here. Oh, well, I'll tell you, I'm in conference, and FSCJ has closed me out of campus. I'm stuck into conference, folks. All right. Oh, yes.
Can you hear me okay?
Yes, I can hear you.
Okay. Are you able to make folders?
Pardon?
In the Files tab, when you go to Courses, are you able to make like folders or something?
I've done that before, but what I would like to do is everything that I put in that folder, I want a separate file so you can separate it and pick it without going through at least that additional step. When she said there's a different lesson 4A on file, that is the beginning actually of chapter 5, and I've got one more thing I want to discuss, and that is circular motion. And I have spent quite a bit of time trying to find my circular motion file. So what I was going to do next was go to a whiteboard and talk about circular motion. Can we just go ahead and finish chapter?
It's these file names are very confusing, and I just think you might not have to rename them, and it would clear it up more easily if you just made folders with the right names for everything.
Miss
Well,
Newberry, I'm taking a screenshot of these just so that I have them. Can you go to the next page for me just so that I can screenshot each page so that I can, so you don't have to like send me
Okay.
anything?
Thank
Okay.
you. How's that?
That's perfect. I got that page. You can go to the next one if you can.
Yeah, I didn't obscure it that much, I don't think.
All right, I got that one. Can you go to the next one?
There you go.
Perfect. I got everything. Thank you so much.
I tell you, the fact that I've got this file sitting here tells me that, and if it's not the same file that's on the home page, then something has been scrambled, and I'll add it back. And when I finish, I'll send everybody an email, because this is a pretty good summary of another way of working these problems. And notice the book only gives you equations to find the range and the peak. And I've given you a technique for determining everything along the path, whether or not it's actual height, its location, its time, its velocities. I think all of you can kind of agree with that, particularly as we dealt with where it was after 10 seconds. Okay, I'm going to go then to a white screen. Close that. Oops. Yoo-hoo. Should have disappeared. Oh, do this. Get rid of that. Come on. All right, here we go. Gonna do it. Oh, come on, folks. Oh, I know I can upload that again. I'll get rid of that. Thank you. Got it. Gotcha. All right, here we go. Got it. Okay. The file that's missing covers the last topic that I'm interested in, Chapter 4, and it deals with circular motion. And it means complete circular motion or a fraction thereof. For example, if you were to take a mass on the end of a string, and if you would twirl it around your head, it would, and if you were maybe in a helicopter above you, if you maintain its height above the ground, it would go through a circle. Of course, there's a person standing in the middle. Well, that's a circle. And with a circle, we know that there would be a radius that would not change. The radial distance, just R. And you would think that if you wanted to find the acceleration of the object on the rim, let's say somewhere like right here, you would, and I mentioned this actually when we began our study of one-dimensional motion, you would think that you would take the initial velocity. Now, if you were in a car here and you're about ready to make a left-hand turn, the velocity that you would read at this instant is sometimes referred to as your speed, since it would be reading on your speedometer. For instance, this velocity at this initial position, I, might be something like, let's say 20 meters per second. Just as a bit of review, how many miles per hour would that be? How many miles per hour would this be? How many of you remember the rule of thumb? Is this going to be going over the speed limit if we're on an interstate highway? rule of thumb is 2 to 1. It'd be about 40 miles an hour. And so maybe it's not quite total speed limit, nowhere near 75 miles an hour. And let's suggest that you went around the track and you knew that you had a change in direction, but your speedometer read 20 meters per second all around the track. So if you came back to this position, and if you use the linear definition for acceleration as a time variable change of velocity, namely A equals the final value minus the initial value, what would you get for the acceleration of this motion? Ladies and gentlemen, what would you get for, that's a minus sign right there, minus, 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 over t with the assumption that the original time was 0. I think you would find that the acceleration would be 0. One reason is because we use magnitude values only. In fact, if you go back and use direction, in other words, the direction, I think you would find that you'd get the same answer. This is 20 meters per second due north. I come back to 20 meters per second due north. So they're the same thing again. And you subtract them and you get 0. Well, if the acceleration was 0, then you were not changing direction. So we really have not looked at the use of the change in both magnitude and direction for a vector. When you're dealing with a vector such as acceleration, or for that matter, velocity, a little arrow over it, you must consider not only the magnitude or the number, that'd be good enough, but you also got to consider the direction. Or if you want to, you can say you've got to consider both. With that in mind, I would like to analyze this motion with respect to not only magnitude values, but what would happen as I went through a distance of some kind. In other words, if I were to compare it to, let's say, the velocity at this point here. And of course, I know the velocity has the same value. Whoops, off the board. So that this velocity value exactly equal to that velocity value. And I notice that I have changed direction by 90 degrees, or pi over 2. And I know then, from my graphic analysis of motion, that I have a secant line here of motion, very much like we had in our graphic determination. I'll use a slightly different color, and let's use a line here and go from one place to the other. And I want to ask you a question. Where in the motion that secant line terminates would the instantaneous, now let me remind you, this equation up here was an instantaneous equation dealing with instantaneous values, not secant lines. Where in this quarter turn would the instantaneous value equal the average value? Where would the tangent line equal the secant line that I have drawn? Does anyone have an idea where that would be? Anybody? You may want to go, yes, actually, with regard to projection, if I were to follow a line here, obviously that's at 90 degrees, then it'd point this way, this way, and this way, and you would find a value right in the center where it would measure 45 degrees. I hope these two lines look parallel, and it looks like they meet somewhere along about here. It's usually the midpoint of the distance line, midpoint of the distance, and that's somewhere along about here. Actually, I'm going to use a dot because that was very important. This is one characteristic. If I have, should be tilted a little more, but it's about right there, which represents about just like you said, 45 degrees. Come on, make it a little larger. Yoo-hoo. Right along this 45-degree line. Come on. Click, click. Well, you see the point. Well, if the change in velocity, let's go back to here. If this change in velocity with respect to time, whoops, here we go. If this right here has an equal term at the secant line, I know that I can find what this means once I compare it to the secant line, because these are parallel lines, have the same slope, should represent, this should be the magnitude of that. It's a matter of direction. So what I would like to do is I like to use this expression here. No, I want to use red for this. I want to use this expression right here and add these two vectors. Actually, subtract one from the other. If I take v sub I, it is in the vertical direction, and I'll bring it out. Now, your text doesn't do this. It gives a similar presentation, but it doesn't take this actual vector here, and it brings it over here, and it says, whoops, where's the straight line? Straight line, we'll make that a straight line. Straight line, and of course it has arrow on it. Well, it wasn't quite long enough. And I want to take the negative of this vector over here, which would be the same length as the original, but instead of taking its base to the tip here, I want then to reverse the vector and add it to this particular vector, which means if this is my initial vector and my final vector was going that way, I want to write the final vector as negative of that, or if I take the negative vector and add, if I take the final vector and add the negative of I, doesn't make any difference which way I order it. If I end up with V final, well, since that's written that way, I'll use that. Here we go. I'll use this. Doesn't make any difference what order I have written it. But I'll repeat my diagram. I'm going to go back and do it differently. Oh, come on. Here we go. Got it. Okay. Now, here we go. And my final vector was, take my final vector, but it is the one that's positive, so I'll leave it in the direction of positive. Here's my final vector, and good deal. And that's about a replication of that vector. And then I want to take the negative of my initial. That's what all this up here represents. This right in here is the negative v sub I. So I'm going to take its distance, which would be about that. Add its base now, which is upside down. Add it to my final vector. I'm going to find something with respect to the change in vectors when their direction is considered. Does that look like about the same length? So that's my initial vector, I. My original I. And this was my final vector. Now, vectorially, just like chapter 3, I want to go to the base of the first vector and end up at the tip of the second. Remember, the head to tail or base to tip, tip to base, and go this direction. Now, I have replicated the magnitude and the direction of the final and the initial, which should have had equal length. And I find that the direction of this change in, when the direction is considered, appears to be something along this line right here. Now, these represented instantaneous values. This vector diagram represented instantaneous values. Where along the secant line interval would it have the same value as a secant line? Well, somebody answered that. They said the midpoint of the interval in distance, which is 45 degrees. So I want to take the base of this triangle. Let me use a different color here to emphasize it. Let's use this. I want to take this base and I want to place it exactly where the instantaneous equals the average. And I want to maintain the direction of the final velocity and the initial. So I want to take this right here and I want to put it right here. I'll just mark it. Now, I know some things about this triangle over that one would look like, and this is an effort to kind of verify something. I can replicate this by saying it really went out this direction again. Ooh, too big. There we go. There we go. Went out this direction. Looks about the same length. There we go. Okay. And the negative of the initial, which looks something like that, about the same magnitude, maybe a little bit too long, but same magnitude, same magnitude. And I want to replicate the change in when the direction was considered. I go from the base of the first to the tip of the final. That's it. Let me correct that. Very important here. I'll get that corrected. Don't want to slump it. I want to go fair. Let me use a straight line. I have a better chance of getting it straight, of course, and connect it to the base of B sub F. Okay, there you go. Something else. Yeah, that's too short. I'll correct it so it's a little more evident. What is happening here is notice that I have a direction for the change in this red line, remember, was by direction and magnitude, the final, I want to use script, the final as a vector minus the initial. With that consideration, and notice T is a scalar quantity, put its direction here. So in circular motion, when you consider both the magnitude and direction, and you overlay the instantaneous vector difference to the secant line difference, you see something about similar or certainly congruent triangles. For instance, if I went back to the radial line here, the radial line here, and the fact that the perpendicular to the tangent line is at 90 degrees to the secant line, I think you can find that these two sides have the same magnitude. The velocity up here had the same magnitude as the velocity here, the minus initial velocity. And since they are at 90 degrees to one another, similar sides are in the same ratio to one another. In other words, if I were to give this secant line a symbol of S, I'd recognize that S divided by R would be similar sides to these congruent triangles as to what in the velocity, which is the blues and the red triangle. First of all, the direction of the velocity's magnitude is a little like ours. Would everybody agree? So in the denominator, I could use any one of these velocities as magnitudes since they had the same magnitude. What then would be equivalent to a secant line? Well, that's the only thing left. That is this red, which would be equal to the change in, I'm just going to put a change in the velocity. Now, at first, you probably don't see how we're dealing with a magnitude for this circular motion or circular acceleration. More appropriately, notice it is center seeking. It's the velocity. It appears to be pointing toward the center of this uniform circle. And indeed, this is uniform circular motion. I could divide both sides by time with impunity. The initial time was 0. And I find something very interesting happening. The change in velocity with time, which is what this equation up here was, would be, I'm going to change, I'm going to move this velocity over here. And I realize that this secant line distance over r is always the average velocity, but these velocities were constant, so this right here expression equals the magnitude v, whether or not it's final or initial. I find the right-hand side of this equation is an expression for the magnitude of the centripetal acceleration. The vector in red is exactly equal to the tangential speed, which has to be constant here, squared, divided by time. We have now discussed the uniqueness of considering direction along with time, so that the equation for the acceleration, which is center seeking, acceleration of uniform circular motion, abbreviate that, equals, if you want to, you can call this a magnitude. Most books do not, because the development was one of taking the magnitude of the secant line compared to just the change in velocity with direction, is equal to that constant tangential velocity, and I like to write tangential here to distinguish it from just any ordinary velocity. It had the magnitude of both the initial and the final squared. Oh my, that's a terrible 2. Oops. Divided by t squared. Just developed in your text. The other applications of circular motion deals with when the tangential velocity is changing in time. They discuss what happens when the car is increasing its tangential velocity, and they also discuss in the book what happens if you're slowing down. Just to kind of briefly look at what is happening there, I would like to draw a vector diagram to illustrate what you'd be dealing with. Let's go ahead and look at a velocity that is in the same position, the 0 position with respect to Cartesian coordinate origin, is moving toward the north at some kind of given velocity in time. In other words, this is a tangential velocity. There we go, tangential velocity. At some later point in time, could be a quarter of a turn, it could be somewhere along the line, we find that just like in an automobile, for instance, if you were accelerating in the tangential position, now this is not accelerating in the centripetal position, remember? Your final velocity is greater than your initial. And what you have now is dealing with these linear variables. You'll have not only a centripetal acceleration occurring because your car is moving in a circle, that centripetal acceleration at this point when you're beginning to accelerate. At that point in time, you would use this tangential velocity, and it would be moving toward the center. So this is your centripetal acceleration initially in time. Of course, this would be your initial velocity. And you would also be accelerating along the tangential direction as you're moving in space, something like this, in time. A good way of knowing that your resultant acceleration, if you stay in the circle, the resultant acceleration should also be moving towards some kind of central region in the circle. It's never in the direction away from your circular motion path. If it is, you're no longer in circular motion. You've lost traction with the road and you're going into elliptical, or you're going over the bank of the curve, something like that. If you have your car accelerating in time, notice you now have a vertical acceleration, which is limited. Most of you might realize that it is very difficult for a car to accelerate more than about 5 meters per second squared. Now, I'm not talking about NASCARs that are going over 150, 200, 213 miles an hour. But this tangential acceleration, let me put it in a different color. Tangential, here we go. Put it in this color right here. If you're talking about a car, will not be more than maybe at most, maybe 6 meters per second squared. But this is the acceleration in the tangential, which is totally independent of the centripetal, which was in red. Now, you can only add the acceleration vectors here. You can only add vectors that have the same unit. Let's add these two vectors. They're just like the addition of vectors in Chapter 3. You take one and you add the other. I would like to keep the centripetal acceleration as illustrated and take the base of the second and produce it the same length and same magnitude, so I have just relocated it. So I want to squiggle this out of here. It's gone. And the resultant now, let's do a resultant side. Yep. Would be from the base of the first to the tip of the last one that I added. And notice that, again, the definition of tangent to the rim is at 90 degrees to the radius value, or obviously we have developed a right triangle such that the total acceleration squared, A squared, I'll make it a little bit smaller. Here we go. And this color does not appear to be very well done, so I'm going to go a little bit darker. And I realize that if I know what the tangential acceleration is, and a lot of times you'll know that because you'll just see the change in linear velocity over time squared plus the centripetal acceleration that you found by squaring the tangential velocity and divided by the time. Pardon me, that's not correct. Boy, am I glad I caught that. Let me just white out something here for a minute. The units don't even match here. Nobody caught me. This would be the side of that triangle that was secant line that was the same was R. In fact, I'll put it in here, R. Now the units match. Meter squared over second squared divided by a meter will give me a meters per second squared. The unit here should advise you that something is wrong. And so our radial centripetal acceleration, which we found from v squared over r, and of course then square it, so you get a t to the fourth there. I think there's an illustration of that in your in the work that you'll be doing. Notice that if you're decelerating by the same amount, that vector would be coming out this way with respect to a sub 10. If it was the same length as that, the vector then here would become a vector down in here, and it would still be toward the centermost region. This really concludes the lessons that I intend to cover in Chapter 4, ladies and gentlemen. There is a section on relative velocity. Anybody have any idea why I am not going to do relative velocity? Particularly at this time. We will talk about a little bit of relative velocity in Chapter 9, which is our study of linear momentum. The reason I'm not going to do relative velocities, ladies and gentlemen, is most scientists, most engineers, and most medical scientists do not deal in relative velocities, accelerations, any kind of change in perception based on motion. I don't know how many of you agree with that, but if you think back about how you are going to be performing on the job, you'll probably realize that you're looking at where things are at one point in time and where is things at a second point in time, really on the Earth, which is the same reference frame. Did everybody kind of get that? Or would somebody like to verbalize that a little bit for me? Hello?
What exactly do you mean?
I'm really saying that I have no homework assigned for relative velocity. That's one of the last sections in Chapter 4. In other words, you are not going to be tested on relative velocity. Thank you for asking. Does everybody hear that? Somebody want to verbalize it? Just again. Or somebody want to type it out? Absolutely. And from the student information feedback that I've gotten so far, and I think a lot of them were lost in spam, I'll try to figure out the ones I don't have, but no one has identified themselves as being a physics major yet. And if we had a classroom of physics majors, there would be a slightly different presentation going on at this time, although I did talk a lot about why things are the way they are, particular circular motion, because it's different. But everybody's general information pointed to application. And we don't do applications when relative velocity is a factor. That's just not the way engineering or medicine goes. And if you're building bridges, you want everything to remain at rest. I think you see that. However, if you're really interested in it, I'll mention that this kind of relative velocity is only Galilean, which means the Earth is sort of a stationary reference frame, which literally means that we're not rotating on our axis and we're not moving around the sun. So if you really want to talk about relative velocity, you have to look at how the Earth's moving. And if you get to the relativistic realm, you got to look at its motion around the sun as well. Well, I think you know that this is for the physicists. It's not for you that wants to be building and doing things in an at-rest laboratory frame of reference, although we know we're moving in space. We need relative motion for time travel. Henry, I agree. Anybody going to do time travel? No, 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 no. Oh, thank you. We're not going to study it. Okay. No problem. I was searching for the word. Thanks, Henry. I love that. Ladies and gentlemen, I was going to go to the original lesson, I think 4A that somebody mentioned. It looks like there's 2 4As or something. And I'm having trouble lifting lesson 4B. Not quite sure why. However, I'm going to jumpstart our study and go right to an application of Newton's 3 laws, if you don't mind. I know that all of you have had some physics background, so I know that you are aware of his 3 laws, and I'm just going to verbalize the 3. I think you have a lesson. From what somebody was reading to me, you do have a verbal, I'm not sure it's PowerPoint, but I think it's Word, Microsoft Word, that talks about Newton's first law. Galileo is actually a law of a measure of the inertia of a body. That is the unwillingness of an object to change its state of motion. In fact, if you have something sitting on a table and there's no earthquake and nobody hits the table, whatever's on the table is going to stay on the table unless there's some outside force acting. So Newton's first law really tells you what's not going to happen. It does help to serve to define what we mean by inertia. It's the unwillingness of objects to spontaneously begin to move. And we know that just doesn't happen. Newton's second law is by far the most important. And that leads to an equation that says if you have a non-zero force F acting on a mass, that it will cause acceleration in the same direction as F, which is the force. However, at our level of study, we're going to find that there are many forces acting. In your homework, you'll find usually there's not more than 3 or 4, and you'll encounter only the 4th when we're studying friction, and that's not part of today's lesson. Friction will be the topic of dedication in our next lesson. Right now, I want to concentrate on this second law. With one force acting on one mass and causing that mass to accelerate at A, the equation would be F equals ma. If, however, there are multiple forces acting on a system of multiple masses, at most you will find that at this level we deal primarily with 3 forces if there's no friction, or less, and 3, no more than 3 masses, and many times only 2. Those 2 masses, or 3, will either be on the horizontal, touching one another, so that if you push one in the back, you'll move all 3, or you'll find them hanging in problems in Chapter 5. One may be on an incline with a cord running over a pulley at the top of the incline, and a mass or 2 hanging vertically parallel to the front surface of the incline. Those are the type of problems you will encounter in beginning with, I believe it's section 6 or 7 of Chapter 5. Sections 5.1 through about 5.6 are talking about the 3 laws. Just before I get into my sample problem here, which is the next part of the lesson, the 3rd law is perhaps the most misunderstood. It is what some people call action-reaction, which means that for every force, for every action, there is, excuse me, there is a reaction force. Reaction means a force in the opposite direction. Wait a minute. We just studied circular motion, and we just found out it's possible to have a centripetal acceleration causing or being the result of some kind of circular force acting. And of course, that is Chapter 6. So let's don't look at the cause, let's look at the effect. The effect was A sub c toward the center of the circle if the velocity had the constant magnitude. Newton's 3rd law and 1st law apply only to inertial reference frames. Inertial reference frames are frames of reference that do not accelerate. So Newton's first and third laws do not apply to circular motion that we just finished discussing. However, Newton's second law is universally true. It is applicable to circular motion, even if the tangential acceleration was changing, as well as one-dimensional motion, two-dimensional, three, if you want to call time the fourth dimension. For that reason, I would like to start applying Newton's laws to a situation today, and I may not finish this presentation because I'm not going to rush through it. It is so important. In fact, on your test on the 18th, Newton's second law has more problems on your first test than any single concept. I'll repeat that when I'm reviewing just the lesson before the test, and I'll tell you how many problems are from each chapter. With that in mind, I would like to get to a typical problem, which is lesson 4C. Let me kind of pull it up. Here we are. All right. I've already lost somebody. Some person has left. I hope they come back, because here's an application of Newton's three laws. Can I apply Newton's three laws? Because I'm considering three blocks on a surface next to each other with a 200 Newton force pushing on the 4-kilogram mass as shown. There's no friction. You haven't studied that yet. Somebody say, no kidding. John, what were you referring to? No. Yeah, do you hear that? Okay. Oh my. I needed a laugh. Okay. Notice that I have sort of a pictorial view of this. Sometimes in homework they'll give you also a pictorial view, sometimes not. Okay. Folks, come on, let's quit talking about Prevent 2020. I say amen to that. I don't want to live another year like this. It's not fair to human beings. Okay. We do. No. Stop the comments. Let me talk. Okay. Thank you. Determine the acceleration of the system and the internal forces. Ladies and gentlemen, if you're going into some kind of mechanical engineering, for that matter, almost any kind of engineering where you have masses or forces acting on masses that may have different shapes, you're going to have to contend with internal forces. In fact, some people refer to them as hidden forces. I had a student that left FSCJ many years ago, may have been 2 decades ago, that he went to the Florida Institution of Technology, FIT, which is a private school that guarantees you employment when you leave their institution. In fact, they will keep you on until you find a job. I had a student to call me. That was way before internet. And he said, Mrs. Dewberry, you'd be surprised how they really beat into my head the concept of internal forces acting in almost any system that an engineer would interact with, because internal forces always sum to 0 if you look at the system externally. Oh my, the rain started falling. It's crying. The reason is, if they're hidden, how in the world can an engineer deal with internal forces if they're always hidden from the external or macroscopic view of the mechanism? Well, we're going to have to dig a little deeper into Newton's laws, because it is part of how the first law is applied and the third one is applied also. First, you would want to realize that all of these masses, since once you start pushing them, notice it's horizontal, will begin to act as a single 17-kilogram mass. And again, it would move to the right, going directly to Newton's second law and dealing with a one-force, one-mass system. All right, come on. No more comments, please. Does everybody get the message? Come on, folks, I need some responses. I'm being deadly serious here. The reason I gave you the example of the FIT student is trying to emphasize the fact that this stuff is not easy, and he called me to tell me, thank you for talking about internal forces. Nobody at this school seems to understand what's going on. So I told him how to do it. And of course, they thought he was just I think we were a community college then, and they didn't think he knew anything, but by golly, people were seeking him out so he could explain how the third law applies to internal forces, and nowhere in your chapter 5 does it say that. If you don't really want to listen to me and make your comments, ladies and gentlemen, just leave conference so that I can teach
Professor,
the
I'm
others.
actually glad that you said that because I was just going to read the book. I've been so freaking lost all session. Like, I've just kind of been tuning out because I'm that lost. Like, I don't want to waste everyone's time trying to make you repeat yourself for repeat.
That's
80%
okay.
Um,
You know, I told you, this is not a good learning process to go online. And I notice I have also referred to your experience in physics prior to coming to a physics or calculus. And I know everyone did not have maybe even a certified physics person teaching you physics. This happens in the high schools all the time. In fact, when I left Terry Parker, they didn't want me to go to the college because I was teaching an advanced placement program at the time. I had just earned my master's in theoretical physics, but the teaching conditions at the college were better and better for me and my family. So your comments are well respected.
I think I'm actually going to make a website that may fix all of that. And I've looked at a lot of websites similar to it, and none of them really come close. And I think it might actually revolutionize the education system. So I hope it's worth my time.
Well, I'm trying. In fact, when they pulled up all my static PowerPoints, I found that someone else had put their name by my work. I didn't even complain because the person that actually copied my work while I was retired has since passed away. And of course, it's flattering when somebody wants to use your work or imitate you, but I don't know if they sold it or not. It's certainly static, and it's the rudimentary PowerPoints that they were doing this 25 years ago. The reason why the dean asked me to teach it, she knew I had these lessons. She also knew that we had tried to do lectures online in the 1990s with students coming once a week for the lab. And of course, when they came for the lab, I did a lot of teaching, which we don't have that option. Which means my tests have been modified to fit a lot of what I teach. And your homework has been restricted to pertinent, how many remember I said pertinent homework problems? Now, I hope you interpret that to mean almost directly related to test, I hope, to be a little blunt, or a little more direct.
Are these lectures recorded?
This failed to start recording. It may be the weather. I don't know what. This happened in my other class last Thursday night. We're still trying to find out what. Oh, thank you. Could you share it? Is this John? Thank you.
Are you just putting these on YouTube?
Yeah.
I mean, I would
I
prefer if you made them public. If the professors
I would
okay with
too.
it.
Yeah, I believe that anything I've generated is public a property. In my lifetime, ladies and gentlemen, I have been paid very well.
Just
In
don't
fact-
monetize it. Dear God, that'll make people mad. Hmm.
You're right. I agree. My students have encountered that.
All right, thank you so much, Sean.
Oh, yes. I appreciate it too, John. I don't know what's part of the problem is they know that I have long hours, and they even mentioned that if it records, it may only go 60 minutes, ladies and gentlemen, and then shuts down. Last Thursday, when I tried to record your class intermittently, it wouldn't even record for my second lesson of the day. It's almost as if we're limited, and I objected to that. If you're going to schedule a class for 3 hours and 20 minutes, whatever we have, you better give me a video time. This is a limitation on Canvas because Blackboard didn't do that to me. Oh. Okay. Notice that I have the equation. Then I have substituted the values. I have 200 newtons that is acting actually at 90 degrees is one way to observe, those of you that remember some of your other physics, and I divided by the mass. So I really solved this equation for acceleration, and notice that its value was 11.8 to 3 significant figures meters per second squared. I have just a few more minutes, so I'm just going to say very quickly, this would be the acceleration of this entire system. However, 200 newtons is not acting on every part of these blocks up here. The 200 newton is acting only on the 4 kilograms. That's the immediate contact force that's mentioned in the lesson. I think somebody was reading lesson 4A that wasn't the lesson 4A I had up. I'll do maybe 1 or 2 more frames, and then we need to go to supper. A free-body diagram for this system includes all forces acting on the system. And notice that we have the entire weight, which would be, what was it, 17 kilograms? Yes, 17 kilograms multiplied by the acceleration due to gravity, and you should be familiar with that. And notice that since it's a vector, you might even say multiplying by a minus. In order to get the direction of the weight, it's always at 90 degrees to the surface when it's flat. Notice we're on a flat surface. And notice that since this is a force acting on this mass, if it's the only force, it's going to go through the table. So I theorize immediately, there must be another force such that the sum of forces in the vertical comes to 0. And that obeys, actually, Newton's first law. The sum of these forces is 0, then it's not going to be jumping up and down. That's why I know I have a normal force, and we get that from saying the angle between it and the surface is 90 degrees, but it's a little like little segment of pushback from the surface here is acting all along vertical, and we sum it to one large pushback force, which exactly equals the weight. Which means if I consider the direction of the force, which is at 90 degrees to that vertical, no part of this force is going to go into lifting or compressing the mass. A lot of you going into mechanical engineering, you may want to take note of that. No component is going to change the weight, because if you push down on this thing with your hand up here, you have increased the pushback force of the surface, unless it goes through the table. And our assumption is the table is rigid enough to support the weight. In other words, we're not going to have any bending of surfaces. The only external force enacting besides weight would be the pushback force of the surface. If you were asked to draw a free body diagram of the entire system, this would be what I'm expecting. I do want to take this perhaps one frame more. Yeah, but notice I have a free body diagram now for every one of the masses, including the fact that the 4 kilogram was reluctant to change its state of motion, so that when the first block started pushing on it as a consequence of the applied force, it pushed back. Here's my internal action-reaction. This force right here caused the inertia of this body to say, oh, no, you're not. I'm going to push back for the same amount. And notice that if you add them, they cancel. Then notice the middle block is pushing on the last block with this force. This mass has some inertia too. Its unwillingness to change its state of motion, and will push back with the exact same amount. These forces will sum also to 0. Thus, the fact that internal forces are not apparent. A good example of what we're trying to say is to calculate this force right here. That's a consequence of the middle block pushing on the end block, and see if that force, when applied to this mass, will produce an acceleration for that mass, the same acceleration as the system has. And if it does, we have identified a way of getting at internal forces. I'll leave you with that thought, and I'm going to come back to this slide, and we're going to analyze this system until we know all internal forces and free body diagrams. And I'm also going to do something with inclined planes. The next lesson deals with friction. And I will be presenting situations with no friction and then changing the same situation to friction in order to buy some time back, because I did not quite finish today's lesson. It is about time that we finish up. You can talk now, everybody. And I've got to close off because I have to get something, a little bite to eat, and then I have a class at 5:30. I hope that we clarified some issues with respect to the lab analysis, the actual class structure a little bit. And thank you, John. I see what you got. And I'll just sign off for now. You're excused for the lesson or the day. And I hope it's not raining as hard where you are as where I am. It's just pouring here. Okay. Have a nice day, everybody.
Have a good day.
You too. Take care.
Thank you very much, gentlemen and ladies.